When designing logic circuits, the term fan-out often comes up. Most of us remember that fan-out refers to the number of gates that can be connected to the output of a logic gate while still functioning properly and reliably. For example, with transistor-transistor logic, or TTL gates, you can connect the output of a single AND gate to about 10 other gates. In this case, the AND gate is said to have a fan-out of 10. But what exactly is happening with this fan-out business? Let's stick with transistor-transistor logic for our example. A TTL input looks like a resistor connected to the base of an NPN transistor. For the output, there's another NPN transistor. Its collector connects to VCC through another resistor, and this collector is the output of the gate. The emitters are grounded. There are two situations to consider: when the output is high and when it's low. When the output is low, the transistor must sink current through the pull-up resistor RC. This current is VCC minus VCE divided by RC. VCE is the voltage from the collector to the emitter in saturation, typically 0.2 volts for silicon transistors. Now let's connect this output to another TTL input. Now let's talk about the second case. When the output is high, the pull-up resistor must source current to turn on the input of the gate connected to the output. The current is given by the formula IB equals VCC minus VBE divided by RC plus RB. VBE is the base emitter voltage, RC is the pull-up resistor, and RB is the input resistor. So far we've been discussing direct current, or DC fan-out. In real-world systems, input gates also have capacitance. This capacitance, combined with resistance, forms low-pass filters, slowing down the circuit. So, in addition to power supply concerns, designers must consider propagation delays, which set a speed limit on the system. What's a poor designer to do? The Complementary Metal-Oxide-Semiconductor, or CMOS family, has an advantage with high DC resistance. This means DC fan-out isn't such a big problem for CMOS circuits. But CMOS gates have high input capacitance, which leads to propagation delays. That's why, despite its downsides, TTL has remained in use for so long. As with all engineering decisions, fan-out involves trade-offs. In this case, between speed and current sourcing ability. If speed is your top priority, TTL might be the way to go. If you're also dealing with large fan-out issues, you could use a buffer. Most TTL gates have a fan-out of 10, but buffers might offer up to 3 times that amount. On the other hand, if speed isn't a critical factor and power consumption is, like in battery-powered devices, CMOS would be your best choice. Final takeaway. When designing logic circuits, always balance between speed and power efficiency. The right choice of logic family can optimize performance based on your project's needs. And here's a quick brain teaser for you. Why did the logic gate break up with its partner? Because it needed some space to switch states. Thanks for tuning in. Keep thinking, keep designing, and keep innovating. Engage and invite audience to comment, inquire, and discuss. Make the background music fun, upbeat, thrilling, curious, educational, and anthemic.